One of the really powerful things you can use your GDC for is to do regressions. We're going to focus initially on linear regressions. So we want to look at doing a scatter plot, how we would get the equation of a regression line, how we would find the R value, and then how we can use that regression equation for extrapolation and interpolation. So here's our data set and some questions we're going to answer once we have a regression equation. So you'd enter this data into your GDC as so, and then we want to produce a scatter plot initially. So we're going to add a data and statistics page. Down here we're going to have our X value, along the vertical our Y value, and you'll see that it's nicely fit that in for us. So to do the regression, we can go here, we can go menu, actions, analyze, regression, and we get it to show a linear regression. Right? And that's that done for us. So that's a really quick and easy way to get your regression equation. Okay, we can drag this around a bit, but I can't pick a coordinate there and work it out. So to do that, if we go menu, statistics, stat calculations, linear regression, it brings up this window here. X list is X, Y list is Y. And what we can do here is save that equation to the function f1. Click OK, and it gives you those exact same pieces of information that we had before. There's your gradient, there's your y-intercept, there's your R value. Okay, so not a bad R value. We see that the points are fairly close to it. Right? This gives us an R squared, not an R. Okay, all you do is square root that R squared value to get R. But this is much more useful because what you can now do is actually work with that f1. Remember when we saved the reg equation, we saved it as f1. You can flick back in the video and have a look at that menu box that came up. If we now go to a calculator page, we can use that equation, f1. So if I want to find y when x is 11, well, what that means is that I'm taking my equation and I'm substituting whatever my m value was, whatever my c value was, I'm substituting in 11. So in GDC notation, what that means is we have a function f1 of x. We're going to enter it as f1 of 11. So f1 11, hit enter. So when x is 11, f1 is equal to 3.36. Okay, 11 would be there, so this is an example of interpolation. Okay, because the x value occurs within the domain that we've been given. Now, this one, what we're doing is saying that y is 7. Now use the m and the c values to find x. In terms of our calculator notation here, we're working with function notation. We know that f1 of x is equal to 7. So what's x approximately equal to? Well, here's one of those rare occasions when you can use nsolve because of the fact that this is linear. Okay, because it's linear, nsolve is okay. So we go menu, algebra, numerical solve, and we're just going to stick with f1. We don't need to worry about the gradient, the intercept. So we've got f1 of x equals 7, and we want to solve that with respect to x. Okay, the calculator is pulling that f1 function out of the regression that you've done because we saved it as f1, ultimately negative 35.9. And this is an example of extrapolation, because that x value is right down here. It's not within the domain that we have been given.